a couple inputs. And one output. So we plug in x and y, and we'll get out z. Okay. This suggests a natural way to graph these things as well. Right? We've got our point, the plane, and then we've got our height above the plane. So we're going to look at a couple different techniques for graphing things. Right, so we can think of making a table of values for this. We can say, all right, well, here are my x and y's, and then here's my outputs. Right, so we can plug in some points to see what happens. So we calculate out values of our function. Now we get to a tricky thing. Everyone screws this up. It's clear that we should label this guy Z. Right? Z should be the pointing up direction. But how should we label these guys? Should this be X? Should this be X? It turns out in math we have one convention. In computer science they have another convention. So I want everyone to get their left hand. If you're a lefty, please put down your pen. Okay. Now stare at your left hand and look at your left thumb. This guy. Say you are X. You are X. You are X. You are X. Okay, good. This is X. Okay? This is Y. This is Z. Okay? In computer science, the convention is reversed. Okay? But yeah, so in this class, this one is always X. Your left thumb is X. Excellent. So what we have to do now is we have to draw this thing. Sorry, so I mostly teach at Sunday school. Okay, so so at Sunday school you can do this and the kids are like, wow. So sometimes I'll do Sunday school stuff to y'all. It helps. It really ingrains it in your memory. Okay, so we draw this. So now to plot these points, we can plot them on the Cartesian grid. So we go x is 0, y is 1. Right, so this is the point 0, 1, 0. Right, so x is 0, y is 1. Now we want to plot the output of our graph. So our graph goes up to there. Okay, now we go 1, 0, 1. Okay. Now the stuff in the middle gets quite tricky. It's hard to plot things in perspective. So we go to 2, 3, 13. So we go to 2, 3, 0. And now we have to go up really high to 13. Right? It doesn't look like much, right? It's hard to see what's going on here. These live on our graph, but very hard to draw. When we ask the computer to draw it, they can plot a million points like that.
On a test or an exam, will we be required to draw a 3D-ish?
Yes, so the question was, will you need to know how to do this? Do you need to understand the process of graphing things in 3D? Yes. Absolutely yes. But as you can see, it's hard, right? It's hard to draw in perspective. So I want to spend the last couple minutes of lecture talking about a way to get a handle on what these graphs are doing. Okay? A way of understanding this graph that's better than plotting point after point after point. Okay? So this is a new notion of graphing, another way of understanding 3D shapes. Okay, something called a contour plot. Is a collection of curves with different values of k. Sometimes in our textbook you'll see this set referred to as a level curve. So I want to say a little bit about why this is called a level curve. So a level curve is where we always output the same constant. Right? So we're always outputting k. Right? So if we imagine taking a cut of our graph at z equals k, right? If we took a cut of our graph at z equals k, that would all be at the same height k. If we were to walk along that curve, we would never go up or down. We would always be at the same level. Okay, so we call these guys level curves. So we'll make a contour plot of that same function x squared plus y squared. Okay, so we'll make the k equals 0 level curve. What numbers satisfy this? X squared plus y squared is 0.
0, 0.
Right, just 0, 0. There's only one number that does this. Okay, so there's just a single point. Okay, so now we'll make a k equals 1 level curve. Alright, so we're starting, well this is the equation of a circle, so that's good. We've seen that before. Alright, so we've got our k equals 0 level curve, that's just a single point. Then we go a little bit bigger, we go to k equals 1. Right, now we got a circle of radius 1. Okay, and we can imagine the k equals 4 level curve. So I want to say, just sort of in closing, what these curves are. So here's our surface, right? This is our 3D graph. And if we put in z equals 0, right, there's only one point where that plane touches our graph. Right? It only touches at 0, 0. Now, if we raise that up to k equals 1, right? Somewhere in this picture, we're going to get a circle. So this is the circle that we obtain by looking directly down at our graph. So that's the curve that we obtain by cutting our graph at height 1. Here's what we get at height 4. Right, we get another circle. Okay, so what we can do is we can say, instead of graphing this thing in 3D, we can say, okay, its level curves are a bunch of circles. And that tells us sort of structurally what this thing looks like. Okay, so this is a big idea of the course. This is like probably the deepest idea in the whole thing. So we're going to keep coming back to this, but we'll pick it up again on Friday, folks. Thank you.
Thank you very much. So basically, I just had a question about